Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day, everyone. Hi, Dr. Zuhi here, and this is for the course of EPF3110 Mass and Energy Balance. And we already covered the first part of the course, which is about the mass balance. Now we are going to move to the second part of this course, which is about the energy balance. And in order for us to do that, we need to first understand the basic concept of thermodynamics and in energy. So this is the learning objective for the introduction for the class today. We will first introduce you with the first law of thermodynamics, and then we are going to further get some explanation regarding to the basic concept of thermodynamics, such as system, state, equilibrium, process, and cycle. And we are going to also get some definition of some terms such as the closed and open system, as well as the steady state flow. So we're going to start with the definition of thermodynamics. In thermodynamics, by definition, is basically it's about science of energy. Okay, so the word thermodynamic came from two words, which is thermo, related to heat, and dynamic, which is related to power. And it's about the law of nature, which is about the conservation of energy principle. You know, when we have any kind of energy, it cannot be created, nor it can be destroyed. What we can do is just to convert or transfer the energy from one form to another. Example like this diagram here, we learn about the potential energy and kinetic energy. If you can see the rock here, before it's falling down, the potential energy is 10 units while the kinetic energy is 0. When the rock's falling down, the potential energy had reduced to 7 unit only, while the kinetic energy already increased to 3 units. But the total unit for the energy is still 10 units. So this is the basic example of what the conservation of energy principle means. Okay, so for the thermodynamics example, well, actually, for us, we need to also learn that for thermodynamics, we have two law actually. The first law of thermodynamics and the second law of thermodynamics. So, for this course, we are just going to look at the first law of thermodynamics. So, what is the first law of thermodynamics say? Simple expression of the conservation of energy principle assert that energy is a thermodynamic property. That means the energy basically is similar like the conservation of energy principle. The energy cannot be destroyed, nor it can be created. But we can transfer the energy or convert the energy from one form to another. And the second law of thermodynamics, but this is not going to cover in this course, but later in other course related to thermodynamics, we'll learn about the second law of thermodynamics, which which means the energy has quality as well as quantity, and the actual processes occur in the direction of the decreasing quality of energy. That's something you're going to learn later. But first, now we just going to focus on the first law of thermodynamics for this course. Well, if we talk about the basic concept of thermodynamics in terms of the application, all activities in nature involve some interaction between energy and also matter. So it's really hard to imagine an area that does not relate to thermodynamics in some manner. For instance, like if you are looking around your house, let's say there are many parts of your house will have some basic concept for thermodynamics, such as the air conditioning system, the refrigerator, the pressure cooker, some kitchen devices and utensil, water heater, iron, even the computer and the television that you watch is also involved with some thermodynamics because it's involved energy. And from a more bigger view, The thermodynamic plays a major part in designing the process in a factory. Particularly for us as a process engineer, we'll see from one process to another, there's some energy involved. So we need to know the basic concept for thermodynamics in order for us to relate with the transfer of the energy from one process to another. So that's very important application of the thermodynamics that we need to understand. Okay, so let's just do some revision back about a few concepts related to the mass and energy balance. And one of the things that had been covered before during the mass balance part is about the definition of system, surrounding, and boundaries. Okay, so let's just do the revision back about the meaning of all of this term, so that for the energy balance part you will get more understanding about how it work. Okay, so a system by definition is a quantity of matter or a region in space chosen for study. So whatever space that we choose for the study that we want to focus on, that's what we call as a system. For example, like in one production line, we have a lot of processes, right? So just going to draw like box. One box mean one process. Boxes. Okay, so this will go in and then go out and go to box B and go from box C, and maybe in box B this is A, B and C. Okay, so now maybe this also will go out. Okay, so now we want to choose our system. We want to choose our system. It can be either the whole process, the whole processes here, or maybe just want to focus on process A. So when we set A as the system that we want to focus on, so we're going to set our boundary. Okay, boundary is a real or imaginary surface that separate the system from the surrounding. Okay, so this is considered okay. So we're just going to put a boundary. So normally the boundary will be draw like this line, a dot line. Okay, so everything inside of this boundary will be considered as system, and whatever outside of the boundary will be considered as the surrounding. Okay, so similar like in this figure too, you can see here, this is the system, this is the boundary, and then we have the surrounding, which is the things outside of the boundary. Okay, and the boundary can be fixed or movable. We can choose the boundary in only process A, or maybe we can extend to include process B too, or maybe the overall process and so on. It depends to what the focus that you want to choose for our study. Okay, and boundary is the contact surface shared by the both the system and also the surrounding. Has zero thickness, thus cannot contain any mass or occupy any volume. So anything that is related to the volume or mass will be either in the system or in the surrounding. There's no volume or mass in the boundary. Boundary is just a thick zero thickness part that's just going to separate the surrounding from the system. So this is just a very basic thing that you have understood during the mass balance part. Just want to give you some revision about this. Okay, and then we have also the two type of system. One is open system and closed system. Okay, open and closed system. So for the closed system, a fixed amount of mass and no mass can cross its boundary. So for instance like this one, okay, so the gas will be fixed here, yeah, or maybe some other process such as maybe I always give the example about the oven. Yeah, when you put oven for the baking process, you put the mass inside and then you close the oven and then you let the drying, the baking process to happen, and then after it so during the baking process is a closed system. No mass will cross the boundary. Okay, so the mass that is already in the boundary, we're not going to mixed with other mass from outside of the boundary. So this is what we call as a closed system. But in the same time, we also have an open system, in which an open system is known as a control volume. Okay, why we call it a control volume? Because we cannot control the mass. Okay, for instance, like this one, yeah. This is an open system. Some mass will go in and go out all the time. Okay, even during the process. Okay, so what we control is the volume of this water. Okay, liquid or water. Okay, so this is also considered as a properly selected region in a space. Okay, so it usually encloses a device that involve mass flow, such as compressor, turbine, or nozzle, or even filter, like water filter. Flow through these devices is best studied by selecting the region. Instead of focusing on the mass going in and out, we focus on the region and the volume here. So that as the control part that we can control. So that's about the closed and open system, which I'm going to explain a bit more after this. Okay, so let me just give more details about the closed and open system, because now it's not just focusing on the mass, but also it will involve some energy. Okay, as what been mentioned before, for the closed system, that's mean that it's also known as the closed mass system, since the amount of the mass will be fixed in the system. No mass can cross the boundary. Yeah, no mass can enter or leave a closed system. However, by considering the energy in the form of heat or work, still can cross the boundary. Okay, so this is special thing. When we say about the closed system, that means it's just involving the mass. However, if you can see in the figure 119 here, okay, for the mass, this is a closed system with a constant mass. The mass cannot go in and go out. Yeah, but energy in terms of the heat or work can still cross the boundary. Okay, so this is additional information when we relate with the energy balance, which something that you're going to further explore later. Okay, and also just want to highlight, although the closed system is a closed system, that means that no mass will go in or go out. The volume of the closed system does not have to be fixed. Okay, I give you another example. Figure 120 here. This is a closed system with a moving boundary. Okay, for instance, this is a chamber in which the gas inside have a mass of 2 kg and the volume is 1 meter cubic. Okay, but once we heat it up, this chamber, the gas will expand. Okay, from A to B. Okay, so this is still considered is a closed system where the mass is still 2 kg. However, the volume now, instead of 1 meter cubic, now is already 1.5 meter cubic. But this is still considered as a closed system by considering the fixed things that we want. We focus is mass, but the volume is flexible. It can be either expanded or it can be reduced based on the existence of the energy in the form of heat or work. Okay, so it's just going to give you example. So it's a bit different from the concept of the mass balance that we learned before, because now it's related with the energy. Okay, but in the case of, for instance, like isolated system, a special case when neither the energy nor the mass can enter or exit the boundary. Okay, so any when it's stated isolated system, so even the energy cannot go in or go out. For instance, example that I can give you is like a very good thermos, yeah, where the thermos that contain water inside, hot water, let's say. So no heat can go out or go in, and the mass is still fixed in that system. So that's about the isolated system. Yeah. But this is bit different from the closed system, in which for the closed system we still need to consider the movement of energy in or out of the system. For the open system, well, as I mentioned before, is known as a control volume instead of the mass control mass. Okay, so this is due to the fact that the mass will go in and go out, and for example, for devices that normally have this, such as compressor, turbine, nozzle, or filter. Okay, so that's why we need to properly select region in the space instead of controlling the mass. And the flow through these devices is best studied by selecting the region within the device as the control volume. Both mass and energy can cross the boundary of a control volume. Yeah. For the closed system, only energy can cross, but for the open system, both mass and energy can cross the boundary. And it's very interesting by considering that a large number of engineering problems involve mass flow in and out the system, thus model as control volume. Okay, so there are many real problem in the industry relate to open system instead of the closed system. So the open system will be a bit more complicated, but we will learn about it. And I'm going to give you a few examples here. Figure 122. This is an example of an open system. I believe this is like a tank where there is inlet and also outlet here. So just imagine that maybe water will go in and go out, and then what we going to control is the volume inside of this tank. Okay, so this is considered as an open system because the mass will continue going in and going out, and in the same time maybe energy will be also introduced or will be reduced from the system. Okay, and for figure 123a, okay, so here I want to explain a little bit more about the boundary. Okay, in terms of the boundary, because for the open system, the situation is a bit special because we are controlling the volume instead of the mass. Okay, so there are few boundary that we need to understand. Okay, one is the real boundary. So this is a nozzle. Okay, so the real boundary is related to something that's fixed. For instance, like this is the wall of the nozzle. Okay, so the boundary is fixed already, but I mean, like, this is the imaginary boundary where the mass will go in and go out, and this is something that we can control in terms of the imaginary boundary. It can be either smaller or bigger depending to what the volume that we want to control. And in fact, in B, example B here, this is another example. This is a chamber where we have the fixed boundary here, and the fixed boundary normally is related to something that considered like wall or something that we cannot move. Or and then we also have something that is moving, and this is what we call is the moving boundary. Okay, the moving boundary is depending. This is the maybe this is a piston where it's depend the boundary can be moving upward or downward depending to the volume that you want to control. And in the same time, there is another boundary where this is considered as the imaginary boundary where the mass will go in. Okay, so now we have a few type of boundary for the open system. We have the real boundary, fixed boundary, imaginary boundary, and even the moving boundary for the open system. Another concept of a system is known as properties. Okay, so any characteristic of a system is called as property, and this is something related to processing parameters such as pressure, temperature, mass, and so on. Okay, so in terms of these properties, it can be either independent or dependent. Okay, And this also can be divided into two, whether it is intensive or extensive properties. Okay, we start with the first, which is the intensive property. Intensive property is independent of the size of the system, such as pressure, temperature, and density. I'm going to give you example of this. And for the extensive property is dependent on the size of the system, such as mass, volume, and total energy. Okay, so how to further understand and differentiate between intensive and extensive property? Okay, based from this figure 123. Okay, imagine if you have a system where it's consisted of few property such as mass, volume, temperature, pressure, density, and so on. And then after that, we divide the box into two. Okay, we divide the box into two equals part. And based on here, we can say that for the mass, it will be divided into half. Okay, for each section. And for the volume, it also will be divided into half for each section. But for the temperature, pressure, and density, it will remain the same. Yeah. So that's mean for the extensive properties such as the mass and volume, it will be depending on the size of the system. If we divide the system into half, the mass will be affected, the volume will be affected, but the temperature, pressure, and density will not going to be affected by the size of the system. So that's a very easy way for us to differentiate with the extensive property and the intensive property. Okay, another concept that we also need to understand is about the state and equilibrium. Imagine a system not undergoing any change. Okay, so at this point, all the property, including the temperature, mass, volume, and so on, can be measured or calculated throughout the entire system, which give us a set of properties that completely describe the condition or the state. So the state is considered as the condition of the system described by a set of property. In other words, all the property of a system have a fixed value at a certain state. So if this value of the property change, the state will change to a different one. Okay, and this is can be described in figure 126, in which in the first state, state 1, we have a set of properties such as the mass, temperature, and volume at a specific value. And then if suddenly something happened, for instance, like the volume changed to 2.5 meter cubic from 1 meter cubic, 1.5 meter cubic. So this is no longer considered as state 1. This is considered as state 2. So that's the definition of a state. And for the equilibrium, this is something that is really related to thermodynamics. The word equilibrium implies a state of balance. Yeah, so that means the system experience no change at all within a system. A system in equilibrium experience no change when it is isolated from its surrounding. Okay, so for instance, like this one. Okay, imagine that this is an isolated system. That means there's no mass or energy can go in or go out from the system. Okay, so you can see here there's unbalanced temperature inside. We have 30, 35, 40, 42, and so on. So this is not an equilibrium state. But when the system reach an equilibrium state, such as the temperature is now consistent throughout the whole system, so this is what we call as the equilibrium system. Okay, and this equilibrium system have different types. It can be either in terms of the thermal, where the temperature, for example, like this one, same throughout the whole system, but it seems like it can be in in the means of mechanical equilibrium, such as the pressure, no change in pressure and in the point of the system time, or it can be either in the phase of in the form of phase equilibrium, where the mass of each phase reaches an equilibrium, or maybe in terms of the chemical equilibrium, where chemical composition do not change with time. That means no reaction happen. So there are many types of equilibrium related to thermodynamics, either in terms of the thermal, mechanical phase, or chemical equilibrium. We move to the next part, which is about the processes and cycle. Okay, so by definition, process is the change that a system undergoes from one equilibrium state to another. Okay, and path is a series of states through which a system passes through a process. I'm going to give you an example. For instance, like you have a cup of water, and then you want to heat the cup of water so that the temperature will increase. So this is state 1, where the cup of water will be having the same volume, but the temperature is, maybe this one is 28 degrees C. And then we have the process part, and this is the heating process, where at the end at the end of the process, we're going to get state 2 of the system, where now the temperature of the water already increased, maybe at 80 degrees C. And then this is based on the what kind of property that we want to measure. Maybe this is temperature, and this is maybe volume. So a process is the concept of process is the change from state 1 to state 2, and the path for the state 1 to go to state 2 is a definition of the path. And in order for us to describe a process completely, we need to know the initial and the final state, and also the path must be known, and also whether it have some interaction with the surrounding or not. Okay, so here we have another example. Process path indicate a series of equilibrium state through which the system passes through a process. Okay, so imagine this is a piston, okay, from state 1 with volume 1. Okay, so the initial volume is bigger, and then maybe we push it, so the system already in state 2. Okay, so this is state 2, this is state 1, and this is the process path. Okay, the thing that's changed here is the volume as well as the pressure. Okay, so if we have this kind of diagram, it's kind of like really can help us to illustrate the state as well as the process that involved. And when something that this happen, when the process happen, we also will have to consider that not all not 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 all properties will change. The properties again is about the temperature, pressure, volume, density, and so on. Okay, there are cases where some of the properties will not going to change, and we call this as giving a specific name. For instance, like if a process does not change in temperature, we call this as isothermal. And isobaric is referring to a process where pressure is constant, and isochoric or isometric process is referring to a process where the volume is constant. So whenever you have any set of question or any kind of problem and it's stated that it's an isothermal process, you know that the temperature is not changing during the process, or is if the situation involve isobaric process, we know that the pressure is constant. Another very popular term that we always use for any kind of situation related to the thermodynamic, mass and energy balance is about the steady flow process. Okay, so by definition, steady means no change with time. Okay, so a process during which a fluid flow through a control volume steadily. So when it's come to control volume, this is an open system in which most of the situation in the industry, most of the equipment can be referred to a an open system where we try to assume that it is a very steady flow process, so that uh, with the assumption that it's a steady flow process, the total mass and energy of the control volume remain constant. That means that when mass inside of the system, the mass and the energy will remain constant, and then it will go out here. And however, do the properties including the temperature, pressure, and so on within the control volume within this system may change with position but not with time. Okay, I'm going to give you an example. For instance, like this example. Okay, so you can see here we have two system. One is at 1 p.m. at 3 p.m. Okay, so you can see here the mass go in and go out, and then inside of the system, the control volume, where this is an open system, the temperature are different at different position. Okay, and then at 3 p.m. the temperature are different within the same system, but it's remain the same at the specific point. Okay, so regardless of this, but at the end of the day, the energy and the mass will remain the same, and it will not going to be affected by the time instead of the position inside of the system. So that's what you need to know about the steady flow process. Okay, so that's the end for this lecture. I already described you many terms related to the thermodynamic process as well as the mass and energy balance, where all of these terms will be used in order for us to solve question or issue related to mass energy balance later. So that's all for me. Thank you. Bye bye. Assalamualaikum.